On your graphing calculator, I'd like you to enter number 1 into y1. So turn your graphing calculator on, and whatever is in your y equals button, you'll want to clear it out. There we go. Okay, so y equals 2 to the x. 2 raised, so you need to use your little caret button, and then x. And then push the graph button and you can see what it looks like. Push second and then graph, and that goes into your table, and record the values. So negative 2.25, negative 1.5, 0, 1, 1, 2, 2, 4. Plot those points, and let's see what it looks like. I'm going to click back to the graph before I connect the points so I can make sure that I'm making my graph look similar to the one on the screen. Notice this graph seems to increase very quickly to the right. It goes up and to the right very quickly. On the left, what does it appear to be doing? It appears to end on the graph, but if you actually were to zoom in and zoom in and zoom in, this is getting closer and closer and closer to the x-axis, but it's never going to actually touch it, and it's never going to cross it. So your y values, as you move to the left on this graph, are going to become like 0.0000000 something something something. The numbers will get closer and closer to 0 without actually being 0 and without going beyond 0. This is known as an asymptote. I know you've heard this word before because you're supposed to learn about them in Algebra 1. An asymptote, A-S-Y-M-P-T-O-T-E, it's a word that has far too many consonants for the number of vowels. An asymptote is a line that the graph approaches and seems to touch, but if you actually were to zoom in, it doesn't actually touch the line and it never crosses the line. Okay, next. In your y equals button, I would like you to leave y1 in there. So leave number 1 in y1, but in y2, I'd like you to put number 2. And if you want to put number 3 in y3 and do that all in one step, you can. But basically, we need to get number 2 and number 3 graphed. So I'll give you a second to work on that. When you do 2 raised to the x minus 3, you do 2, and then your caret button, and then x. Notice that your cursor is still up in your exponent. Leave that cursor up there and make sure that that minus 3 is up in your exponent. If you happen to have an older graphing calculator where your cursor doesn't go up into the exponent, you would need to enter 2 raised to the parentheses x minus 3. But if you have an 84 plus or above, it should raise up for you. Right arrow brings it down. And the table given to you, they really want you to find where is the y value of 1. The y value of 1 is when you have an x value of 3. The y value of 2 is when you have an x value of 4. So that's going to kind of direct us into which part of this table we want to record. Now, I'm highlighting a specific point just because I want you to notice some things about it. You don't have to do that, but you might see that I've got a red dot up here. We'll talk about that in a minute. So if you haven't already done it, make sure you get number 3 entered. So make that 2 to the x plus 2. So you might notice that I put a red dot. That red dot is where the point 1, 2 was on the original graph. So I put the point 1, 2 in red on all 3 of them because I want you to see that point as a reference point. So what do you notice about number 2? How did this graph move? How did it change? Moved 3 to the right. How did number 3 move from number 1? It moved left 2. Now notice the equations. The one that moved right 3 had a minus 3 in the exponent. The one that moved left 2 had a plus 2 in the exponent. Do you suppose maybe those things are related? Yeah, just a little bit. So let's answer these questions. How does the minus 3 affect the graph? It moves the graph right 3. How did the plus 2 affect it? It moved the graph left 2. So, if it was minus 12 in the exponent, what do you suppose would happen? It would move right 12. Do you notice that it's backwards? Minus moves to the right, plus moves to the left. So if you remember all of the other functions that we've graphed, do you remember that horizontal movement is always backwards? Anything that you do to the x is always backwards. Horizontal movement is backwards. So what effect does the number added and subtracted to the power have on the graph? If it's added, it moves to the left. And if it's subtracted, it moves the graph to the right. Now we do need to talk about domain. Oh, sorry, hold on. Do you think that the graph will touch or cross the x-axis? We already talked about this a little bit. It's called an asymptote. So no, it will not touch or cross the x-axis. It will get closer and closer and closer and closer to the x-axis, but it will never touch it and it will never cross it. Now, our pens and pencils aren't super precise, so when we draw these graphs in, it's going to look like our graph is touching the x-axis. But if you were to zoom in, zoom in, zoom in, zoom in, it's continually getting closer and closer and closer to the x-axis without ever touching it. The domain for all of these is super easy. The domain is all real numbers. You can plug any real number into any of these functions. The range is a slightly different story. Because there's an asymptote, all of these y values are getting closer and closer and closer to 0 on the left side, but they never actually get there. So all of these y values have to be bigger than 0. So y is greater than 0. All right, now on this page, we've dealt with movement right and left. What do you suppose we're going to deal with on the next page? Up and down. So let's turn the page and let's do up and down. Okay, number 5, 6, and 7. I would like you to enter number 5 into y1, number 6 into y2, and number 7 into y3. Get the values out of the table and graph them, and then we will talk about the questions at the bottom. Enter this the same way it's shown, so parentheses 1 divided by 2 raised to the x. For y2, we want parentheses 1 divided by 2 raised to the x. We do not want the plus 1 in the exponent, so you have to push the right arrow to get down out of the exponent, and then you can enter your plus 1. Right arrow minus 1. So especially when you look at these graphs, you can see the horizontal asymptotes, and when you're drawing them in, you pretty much have to envision that there's a horizontal line that our graph is going to not touch and not cross. So in 8a, how does the plus 1 affect the graph? What'd you guys notice? It moves the graph up 1. What does the minus 1 do? Down 1. Notice that vertical movement is normal. Plus means up, minus means down. So what would minus 12 do to a graph? Down 12. And in the next one, we'll write plus moves the graph up, minus moves the graph down. Will the domain and range be the same for numbers 5 through 7? The domain, yes, the domain will be the same. The domain will still be all real numbers. The range, however, I'm going to write C above. And let's actually look at each of these graphs and decide what the range would be for each of these graphs. If the graph doesn't move at all, up or down, like number 5, the range is y is greater than 0. Those values on the right get closer and closer to the x-axis, to y equals 0, but they don't actually get to 0. Basically, number 5, you're constantly dividing the y values by 2. So you're continually dividing by 2, dividing by 2, dividing by 2. Eventually, you'll get 0.000000000 that we would all round to 0, but it isn't actually 0. It's just super close to 0. Number 6, by moving the graph up 1, we're also moving that asymptote up 1. So now our range is y is greater than 1. The range increases or decreases as you move the graph up or down. So what do you think the range on number 7 is going to be? Y is greater than -1. All right, on the next page, we are going to look at stretches and shrinks and flips. As you're working on this page, here are the values from the table and the graphs that go along with it. So take a moment and get these values written down, or do this in your calculator by yourself if you'd like, whichever works. But get these written down and get those graphs drawn. And here's number 8. Get that copied down, and then we are going to start answering the questions. So if you're done with all of this, start answering the questions on your own. Multiplying by 3, like in this graph, stretches it. So this is a vertical stretch. It makes the y values increase a lot faster. In B, multiplying by 1/2 is a vertical shrink. It makes the y values increase more slowly. Multiplying by a -2 flips the graph over the x-axis. And then for D, the differences and similarities between 2 to the x and 2 to the -x. A negative in the exponent flips the graph over the y-axis. Okay, so the domain is always going to be all real numbers for all of these exponential graphs. The one thing that I want to make sure that you make note of is that if the graph is flipped over the x-axis, then the range is going to be y is less than 0. So if the graph is on the lower half of the, if the function is on the lower half of the graph, it changes that range to y is less than 0. All of these y values are less than 0. And I'll keep that up. This is what you really need to know from today. Your assignment today, you should not need to use a graphing calculator. You should be able to look at the equation and figure out what's going on based on each of these letters. So make sure you have that on your notes.